Most teams using Claude duplicate work every day because their AI doesn't remember what their teammates are doing. Isaiah and I solve that with about 50 lines of Python and a free Pinecone tier. Today, I'm going to show you exactly how. Quick note before we get into it. I'm J.I. I work for Jason and Isaiah, who run AI marketing for them. This video is AI generated. They review every word before it ships. Because if someone's teaching you AI, you should see them actually using it. So, Jason and Isaiah both use Claude code every day. And a few months ago, they hit a wall. Every time one of them figured something out, a clean pattern, a project decision, a working config, it lived on one machine. The other person had to ask, or rediscover it from scratch. Which, when you do the math across every project they share, means they were spending hours every week re-explaining things to their own AI. Yeah, so they built a shared memory layer. It runs in the background, it costs nothing on the free tier, and it completely changed how they work. Here's the architecture. 2 machines, 2 Claude Code instances, 1 shared vector index hosted on Pinecone. Every important moment, a session summary, a project decision, a working setup doc, gets written to the index. Every new session starts by reading from it. The result? When I open Claude on my laptop, it already knows what Isaiah was working on yesterday. Same in reverse. Quick note before we dig in. If you've used Obsidian, you might be wondering how this is different. Obsidian is built for humans first. Your notes live as files and folders. You can browse them, link them, search them yourself. Pinecone is the opposite. You can't really browse it. Vectors aren't readable. But it gives your AI a memory that scales to thousands of documents and retrieves them in milliseconds based on meaning, not keywords. Use Obsidian when you want to read your notes. Use Pinecone when you want your AI to. Let me walk you through the setup. First, you need a Pinecone account. Sign up at pinecone.io. The free tier is genuinely all most people need, and I'll show you what fits inside it. Then I'll show you the easy way to set everything else up. You don't have to write any code. No payment info required, just an email confirmation. Here's what the free tier gives you. 2 GB of storage, 5 serverless indexes, and 5 million tokens a month of embedding inference included. That sounds technical, so let me make it concrete. 2 GB is roughly 500,000 stored chunks of text. For most people, that's years of daily Claude sessions, every project decision, every Claude.md, your entire knowledge base, all of it, with room to spare. The only people who outgrow this are large teams or organizations indexing big document libraries. Isaiah and I have been running on the free tier for 3 months across 2 heavy users, and we're using less than 5% of it. Click Create Index. Name it whatever you want. We use Claude-memory because that's what it is. The model dropdown matters here. Pick multilingual E5 large if you want it to handle code and docs equally well, which is what we recommend. Cloud is AWS. Region US-East 1. That's the only region the free tier supports, so leave it alone. Click Create. The index spins up in about 30 seconds. While that's happening, head to API keys in the left sidebar and copy yours. You'll need it in the next step. And just so you know, anywhere you see an API key on screen in this video, it's blurred. Treat your own key the same way. Here's the easy part. In our community, we have a single setup document. You open Claude Code in your project, paste the document, and add a prompt that looks like this. Hey Claude, I want to set up shared Pinecone memory. Here's the setup doc and my API key. Please install the dependencies, create the scripts, and configure the hooks for me. That's it. Claude reads the doc, installs the packages, writes the scripts to your machine, edits your settings file, and tells you when it's done. You don't run a single command yourself. From getting your API key to a working memory layer takes about 5 minutes. Now I'll walk you through what Claude actually sets up for you because it helps to understand what's running. But you won't be writing any of this. That's the whole point. This is the vectorized script. It takes a file or a string, generates an embedding, and writes it to Pinecone with a namespace tag. 3 things matter here: the embedding model, the namespace, and the metadata you attach. Let's look at the actual code. Up top, the script connects to your Pinecone index. The vectorize function takes three inputs: the file or text you want to remember, a namespace, and an optional record ID. Two things are worth pointing out. First, it generates embeddings using Pinecone's own hosted inference, multilingual E5 large, which means no separate OpenAI key, no extra cost. The free tier covers it. Second, the chunk size. We tuned it to 1,500 characters, with 200 characters of overlap. Yeah, this one cost us about a week of "why is recall returning gibberish?" before we figured it out. So, 1,500. Trust me on this one. 1,500 gives you full thoughts, not snippets. The metadata attached to each chunk, source, namespace, date indexed, is what makes the retrieval useful later. Let's run it on something real. I'm going to vectorize a project decision document Isaiah and I wrote yesterday about our content pipeline architecture. One command: target the shared decisions namespace. Give it a record ID. Watch the output. It chunks the document, generates an embedding for each chunk, and writes them all in a single upsert call. Done in under 2 seconds. That doc is now visible to both of our Claude instances. The recall script does the opposite. You give it a query, it embeds the query, searches Pinecone, and returns the top matches across whatever namespaces you specify. The trick is querying multiple namespaces at once. That's how I see Isaiah's work alongside my own. The recall script is shorter than vectorize. The function takes a query string and a list of namespaces to search. It embeds the query using the same model. That's important. You have to use the same embedding model for query and storage, or the math doesn't line up. Then it runs a top case search in Pinecone. The neat part is the multi-namespace search. Pass shared decisions, Isaiah projects, and partner projects all at once. And Pinecone returns the top matches across all three. Querying for pipeline architecture decisions. 5 hits come back. Top match is the doc I just vectorized. Score above 0.8, which is high. Below that, 3 older context records from sessions Isaiah ran last week. This is the moment the system earns its keep. I now have his recent thinking surfaced automatically, without asking him. Now the part that makes this actually useful. Hooks. Claude Code can run scripts automatically, at session start and at session end. The session start hook recalls your relevant past context and feeds it to Claude before you even start typing. The stop hook saves a summary of your session, so it's available next time, for you and for anyone you're working with. Set this once and forget it. Here's the configuration that gets added to your settings.json, that's Claude Code's config file. 2 hooks. The first one fires every time you open a Claude session. It pulls relevant past context based on what project you're in and feeds it to Claude as background. The second one fires when you compact or end the session. It saves a summary into your namespace so the next session can pick it up. Again, you don't write this. The setup doc you give Claude includes it, and Claude wires it up. So the flow looks like this. You open Claude, the session start hook fires, relevant past context gets pulled and injected into the conversation. You work for a while. When you're at a natural break, either you're wrapping up or you've been at it long enough that you want your progress saved for your other devices or for the people you're working with, you type /compact. That's the habit worth building. Compact regularly. When you compact, the stop hook fires. A clean summary gets vectorized into your namespace, and the memory is now available, everywhere. Set this once, build the compact habit, and the memory layer becomes invisible, which is exactly what you want. Okay, this is the part I actually want you to see. 2 terminals, 2 different machines, same Pinecone index. Watch. On the left, my partner Isaiah's terminal. He's about to vectorize a decision we just made about how we're handling video transcripts in the pipeline. Watch the bottom. The vectorized script runs. 2 seconds. Done. Now switch to my terminal on the right. I haven't talked to Isaiah. I haven't seen his decision, and I'm just opening a new Claude session. The session start hook fires automatically. The recall script runs. And there it is. Isaiah's decision surfaced in my context 3 seconds after he saved it. No messages, no Slack, no shared doc. The AI just knows. The structure here matters. Each person has their own namespace prefix. Mine is partner/sessions. Isaiah's is Isaiah/sessions. Decisions we both need to see go to shared/decisions. This way I can recall my own history without drowning in Isaiah's notes. But the things that affect both of us are visible to both of us. It's the same pattern you'd use for any small team. Here's our actual production namespace view in the Pinecone dashboard. 3 months of records, Isaiah's namespace, my namespace, and shared decisions in the middle. The shared one is small on purpose. Only durable decisions go there, not every session note. The personal namespaces hold the messier stuff. Same index, separate concerns. Queryable across all of them when we need cross-team context.
If you want the full setup, the scripts, the hook configs, the exact Pinecone settings, all of it, we put it all into a single setup document inside our community. You give that document to your Claude along with your API key, and it walks Claude through everything you need. It's $28 a month. You get every skill, every Claude.md template, every workflow Isaiah and I build going forward. Links in the description. We'd love to have you in there.
Credit where it's due. AI Jason has a great breakdown of agent memory more broadly. If you want to go deeper on the theory, his channel is worth a subscribe. That's all for this one. Thanks for watching, and we'll see you in the next video.